Assalamu alaikum. I'm Abdullaev and I work as a senior teacher at the Department of Electrical Engineering of Regional Polytechnic Institute. Now, I want to make a paper presentation on the topic a review on power transformer failures, analysis of failure types, and causative factors. This article was prepared Corporation Professor Teachers, Regional Polytechnic Institute, and the Kokand branch of Tashkent State Technical University named after Islam Karimov. You can see the six also of manuscript. Damage to power transformer in 610 kilovolt voltage networks mainly occurs in 100 kilovolt ampere, 160 kilovolt ampere, and 150 kilovolt ampere power transformer. One of the factors that causes the failure of the power transformer is the irregular implementation of restriction on the supply of electricity to electrical consumers. This fault mainly damage the winding of the power transformer. Nowadays, the electricity demand is increasing day by day. Fulfilling this requirement requires increasing the reliability of the energy system. Power transformers are one of the energy system's main electrical devices, and these are a crucial part of energy system and one of the valuable components. Power transformers are used in the transmission and distribution of electric energy by changing voltage and current from one value to another while constantly maintaining the frequency and power value. Before preparing this article related to power transformer damage, published in the recent year were studied. If we dwell on them, the research result of Islam Lee et al. Showed that the short circuit resistance of long-term service power transformer is lower than that of new transformers. Ariastina, Giorantari, Solin, Yalonde have improved service quality and reduced operating costs of aging transformers by applying various condition monitoring and inspection methods to diagnose internal faults in power transformers. Chinese scientists Bai Gao Liu and others conducted scientific research on the factors that accelerate the aging of power transformers, such as electrical, mechanical, chemical, thermal stress. In addition, a number of scientific works have been carried out by scientists to identify and diagnosing damage to power transformer. Various international standards such as IEEE STD 57 and IEEE PC 57.104 drop D6.2 IEEE STD 62 have been developed for transformer failures and improve power transformer reliability. Monitoring the condition of power transformers may protect transformers from damage while at the same time achieving economic and energy efficiency gains for enterprise. By applying measures developed based on monitoring and diagnostic results, it is possible to increase the operational reliability of power transformer. This is important in ensuring the stability of energy system. When it comes to methodology part, this figure shows the sequence of writing the article on power transform failures. At first, multiple research publications such as IEEE Explorer, ResearchGS, Springlink, ProQuest, Elsevier, and Google Scholar were chosen to construct the data in this analytic research work. Data was collected from database using keywords such as failure, power transformer faults, diagnosing methods, and others. Among this collected data, articles published in the last 25 years were selected. And among these articles, more than 200 articles were reviewed, and more than 60 articles relevant to the topic were selected for use. During the review of the selected articles, the heading of the manuscript were formatted. Then each article was studied in detail, and the information corresponding to the article heading was placed. This strategy helped us, especially me, avoid reviewing the article multiple times. The condition leading to the damage of the power transformer were determined, and the chart of values of power transformer caused by various factors was constructed. After the analysis of the power transformer and its components, and the function of this component, the types of failure and cause of their occurrence were analyzed. The method of diagnosing power transformer was studied, and the diagnostic methods that were found to have a high level occurrence for identifying failure in each component was cited. A statistical analysis was conducted on 610 kV voltage power transformers in Fergana region. As an assist to research, we used the IEEE standard S57.125. In 2022 and 2023, failed power transformer in the 610 kV power grids in Fergana region were analyzed. A line graph displaying the relationship between electricity capacitance and the number of failures was carried. The next slide we can see. In this case, since most of power transformers in power network are in the range of 25 kV ampere and 4000 kV ampere, power transform in the power range was selected. A total damage power transformer of 6 kV and 10 kV were obtained. An analysis was conducted on the damage to the components of power transformers that failed. Made chart of failure analysis of elements of damaged power transformer by location was built. Summarizing the result of conducted research, the conclusions were presented. The using of power transformers by established standards allows them to be used effectively for a long time. This increases the reliability of the energy system. The probabilities of transformer failures and other working life factors depend on the primary fault origins, such as electrical, dielectrical, thermal, mechanical, physical, chemical, and unclassified stressors. Port transformers fail for several reasons. This you can see these pictures also. This includes insulation damage, circuit damage, overvoltage, and others. According to the opinion of Sins, which is Jasper Sins, Sanjay Sins, Amanpreet Sins, the main cause of power transformer failure are insulation failure and line storage, which make up 46.5% of the factors that cause the damage power transformer. According to the research conducted by Mehmet Zile, the main cause of the failures were voltage winding faults and insulation degradation. According to the result of analysis of the cause of failure of power transformer, the failure of electrical device occurs due to the effect of long-term short-circuit current that causes turn-to-turn short-circuits, burning, and explosion, and geometrical changing of transformer winding. In this table shows the result of analytical study on the damage to components of power transformers. Using this table, it is possible to obtain information about the function performed by the transformer components, the conditions that cause their damage, and the types of component damage and method of their diagnosis. To detect early damage to power transformers, various diagnostic works are carried out on them. Using that diagnostic method, it is possible to identify the damaged component of power transformers. Also, knowing the damaged components in the power transformer, it is possible to predict its damage factor. Based on this condition, we may be able to create strategies to limit the damage to power transformers in the future. Today, several diagnostic methods have been developed, and the solid gas analysis, frequency response analysis methods stand out among other methods due to their high accuracy and wide application in detecting damage to the active part of power transformer. In 10 kV network, power transformers fails mainly due to the damage to winding. Especially one of the most common damage that cause failure of power transformer is the displacement of the winding in the axial direction due to imbalance of force in the axial direction. In this slide shows that failure statistics and many types of damage affecting power transformer of 10 drop 0.4 kilowatt in the distribution grids of one of the Russian power systems. 25% of all transformer failures were due to mechanical displacement of winding, and 18% of transformer failures result from torn short circuits. This figure shows the dependence graph of power transformer damage on its elements. When components like winding, insulation, and core are damaged, the power transformer fails. The most damaged power transformer element is its winding and insulation damage, which accounts for 41% of total damage. Bushing is next place with 14%. The failure of power transformer is directly related to the damage of its contractive active parts, winding and core. It is equally important in any voltage network that the active parts are damaged and power transformer fail. Ushakov and others believe that defect in the active parts specifically the winding, which make up 43% of 10 drop 0.4 kilowatt transformers and over 30% of 110 kilowatt voltage class transformer with rated powers of 16 to 40 megavolt amperes are one of the main causes of these state events. This slide is about analysis of damaged power transformer in 16 kilovolt networks in Fergana region in 2022 and 23. In 2022, the most frequency damaged power transformer were 160 kilovolt amperes and 100 kilovolt ampere power transformer. In 2023, it was 250 kilovolt power transformer. The series of least damaged power transformers are led by 25 kilovolt amperes and 50 kilovolt ampere power transformer in 2022 and 2023 respectively. This slide shows about analysis of damage for transformer in 16 kilovolt networks in Fergana region in 2022 and 2023. This slide shows the result of statistical analytical study conducted in Fergana region, which is damage to power transformer elements by location is expressed in percentage. More than 1/3 of total number of failures of power transformers are transformer failure due to damage to the winding. Scientists Akbar Kazi, Sabit Khan, and Karim Ford investigated the damage to power transformer and their components. They didn't take into account the effect of restriction imposed on the supply of electricity to consumers on power transformer failure. But our research found that restriction placed on the delivery of electricity to consumers negatively affected power transformer working life. Mr. Sins, which are Jasper Sins, Sanjay Sins, and Amanpreet Sins, noted that power transformers of 25 kilovolt ampere and 63 kilovolt ampere and 100 kilovolt ampere was the most damaged in 10 drop 0.4 kilowatt power lines. In our research, there were 100 kilovolt ampere, 160 kilovolt ampere, and 250 kilovolt ampere power transformers. The result of the study in Fergana region shows that the failure of power transformer increased in the winter season. which refutes the result of the study of Sins, Mr. Sins. As one of the reasons for this, we can point to the restriction imposed on the supply of electricity to consumers. Recent studies have shown that the components most affected by power transformer failure are protective device and insulation damage. But moreover, our investigation reveals that this component is a transformer winding. Our research shows that the failure of power transformer is directly related to the damage to its components. And in the future, research can be carried out to identify damage in power transformer winding and improve its diagnostic method. Recent observation shows that power transformer failures can be reduced by reducing constraint on supply of electricity to consumers. In conclusion, we can say that the research determines that when eliminating power transformer failures in 16 kilovolt voltage power networks, it is necessary to pay more attention to 100 kilovolt ampere, 160 kilovolt ampere, and 250 kilovolt ampere power transformers, which have the most failures. It is by reducing damage to power transformers of this capacity that we can reduce the number of total failures of power transformer. This has a positive effect on increasing the reliability of electrical network. The observation from this study suggests that there is a need to regulate the restriction on the power supply to electrical consumers. In the implementation of scientific research work on the damage to power transformer parts, more emphasis should be placed on reducing the damage to the winding, which is the active part of the power transformer. Thank you for your attention.